Hello, Intermediate Algebra. Today we look at our second half of section 4.5, which is Systems of Linear Inequalities. This is also the last lesson of chapter 4. We are going to start with a warm-up, so I want you to pause the video and try to graph the system of linear inequalities. Y is less than 2x, y is greater than negative 3, if you know where to start. If you don't, follow along, because I did pick this problem to explain one little thing that maybe hasn't come up in the videos. First of all, when I graph y is less than 2x, remember I first find the y-intercept. Since there's no number here, it's 0. The slope is this number, which is 2, or 2 over 1. So I plot a y-intercept at 0. I go up 2 over 1. Remember, when we graph an inequality, next we decide solid or dotted based on the symbol. Since it's just less than, it's going to be a dotted line through those 2 points. Should have had this. And then last but not least, we need to do a test point. 0, 0 is on the line, so I am not allowed to test that. So I chose to test 0, 2 instead. I tend to like to test a point that has 0 as an x value when it's in slope-intercept form, because then I ask myself, is 2 less than 2 times 0? The reason I like x being 0 is because it always makes that 0. Is 2 less than 0? No, which means this is not a solution, which means everything on the other side of the line is. Okay, so the only thing different about that one was that it had a y-intercept of 0. But then we have this line, y is greater than negative 3, or this inequality. We haven't talked too much about vertical and horizontal lines. It did come up in one of your homework problems, so depending on your teacher, I'm not sure if you were looking at it, but if I had just y equals negative 3, that means for every point on the line, y has to be negative 3. So if I think about that, then on this point, I would go down to negative 3. That means this is a point on that line. But it also means this is a point, and this is a point. For all of these points, y is negative 3, which means that it's a horizontal line through negative 3. Now, second, I have greater than negative 3, so a greater than means that it's going to be dotted. So I do a dotted line through those points. And last but not least, I shade. So I am allowed to test 0, 0. You might say, well, Miss Minsky, there's not an x. That's okay. I just plug in 0 for y. And I ask myself, is 0 greater than negative 3? Yes, so that is a solution, which means I shade up. And remember, last but not least, the overlap portion. This section right here is the actual solution, meaning every single ordered pair that falls in that red section is a solution to the graph. Nothing on the lines, though, because both lines are dotted. All right, today we're going to flip it. Today you are given the graph and you're asked to write the system of inequalities. So this goes back to being able to write equations of lines given the graph. So I'm going to write my blue line in blue, so the blue inequality. And again, we did this for a single inequality, so you're just going to do it twice. When I look at the blue line, again, I first identify the y-intercept, which in this case is 4. I find another point on the line to find slope. I go down 1 over 1. So my slope is going to be negative 1 over 1. These two pieces of information tell me that my mx plus b is going to be negative 1x plus 4. But then we have to go through the process of figuring out which way the inequality symbol faces. So we said first we ask ourselves solid or dotted. This one is solid, so it's going to be underlined. And then we kind of work backwards with the test point. So if I use my test point of 0, 0, the blue line you can see is shaded this way. So when I test 0, 0, I need it to be no. Okay, so when we did these in the last section with just one linear inequality, we said, okay, now write your inequality, y compared to negative 1x plus 4. The last piece we're figuring out is what does that symbol have to be? So we go through and we put in our test point, but we leave that blank for the inequality symbol. And in the end, this simplifies to 0 compared to 4. And now we have to think about this inequality. It must be no, so not true, and it must make it a solid line. So if I need 0 compared to 4 to be no, then I would have to say 0 is greater than 4. Because if I had said 0 is greater than 4, you'd have said, no, it's not, Ms. Sliminski. And then to make it solid, I have to underline it. Okay? So I go through this process where I think about it and I identify, okay, it must be no and solid. I figure out which way that inequality goes. And then I take that and I put it back up here. And again, I got this information from this work up here. All right, so now I go back and I say must be greater than or equal to. So that's going to be my first inequality. The fact that this is a system just means I have to do it again. So now I'm going to write the inequality for the red graph. Again, I find the y-intercept, which is at 3 this time. I find the slope to get from one point to another. I went up 2 over 1. So my slope is 2 over 1, which simplifies to 2. So if I just put these two together, it would give me 2x plus 3 as an x plus b form. Then I identify that the line is dotted, which means in the end I will not underline my inequality. And then for the red, if I tested 0, 0, it's actually yes, because it's shaded that way. So when we test 0, 0, we need it to be yes. So again, we work kind of backwards. We compare y to 2x plus 3. We plug in that 0, 0 test point, and we get 0 compared to 3. But again, this, based on this information we found up here, okay, so I'm using this idea, whatever I put here must make it be yes. So I need to make it a yes statement. So is 0 what compared to 3 is yes? 0 is less than 3 and dotted, which means I don't underline it. And once I identify this as less than, I just put it up here. Okay, so this is my second inequality. Now, last but not least, don't forget to write your answer. So my system, which is what it was asking me to write, is the combination of these two inequalities. The first one is y is greater than or equal to negative 1x or negative x plus 4. And the second one is y is less than 2x plus 3. So my final answer is this. The stuff below is just the work I needed to get there. Let's do one more together. The first thing I want to point out about this one is that you need to be careful with your axes when they're labeled. Okay, so this is 0, but then this is 4, which means that the boxes are actually counting by 2. Okay, so make sure you take that into account when you're doing your work. That'll come up on the one you're going to try in just a second as well. Okay, so let's go through this one. I'm going to deal with my blue inequality first again. Again, I always find my y-intercept, which is at negative 4. So if you didn't recognize that the y-intercept or that the axes were counting by 2s, you would get that wrong. The slope would actually be the same. So to get from here to here, because they count by 2, I technically go up 2 over 4. That simplifies or reduces to 1/2. You can see that if I just counted the boxes, I would have gone up 1 over 2. So the labeling of the axes wouldn't have affected my slope, just the y-intercept. But I do get 1/2 x minus 4. When I go to figure out the inequality symbol, first I recognize that it's solid, so it'll be underlined, and the test point of 0, 0 compared to the blue graph was no, because it's shaded underneath. So when I compare 1/2 or y to 1/2 x minus 4, plug in zeros, 1/2 times 0 minus 4. 0 compared to negative 4 must be no. So how do I make 0 not compared to negative 4? If I said 0 is less than negative 4, that is not true. So I need my symbol going that way, and it must be solid. So I do need to underline it. Move that back up. I get my first inequality is y is less than or equal to 1/2 x minus 4. I switch to my red curve, line. My red inequality, the y-intercept in this case is 0, which is going to pose a bit of a problem with my test point. The slope, if I go to the next point, I go down 4 over 2. So it's negative 4 over 2, which is negative 2. So I get negative 2x plus 0, which is the same as just negative 2x. It is dotted, so I won't underline it, but I can't test 0, 0 because it's on the line. So in this case, I chose to test 0, 1 instead. Okay, and compared to the red line, that was true. So I tested 0, 1, which was yes, which means that I take my inequality, y compared to negative 2x, 1 compared to negative 2 times 0, 1 compared to 0. Must be yes, and dotted, so don't underline it. So 1 is greater than 0, so this is a greater than. Don't underline it, that's my second inequality. Last but not least, I write my system as my final solution. Two inequalities are that y is less than or equal to 1/2 x minus 4, y is greater than negative 2x. So this is my system. Okay, go ahead and pause the video. I would like you to now try to write this system by yourself. When you're done, unpause it to check your answer. Remember to be careful. These boxes do count by 2s. Okay? Careful with that. All right. Hopefully this system is what you got. Okay, so check the top. You should have had y is less than or equal to x minus 2. Y is greater than or equal to 3x plus 2. If you didn't get it, pause the video, check your work, and figure out where you went wrong. Last but not least in this section, just like all the other sections of this chapter, we do want to be able to solve word problems using systems of inequalities. So now we're back to what we had to do in sections 1, 2, and 3, and that is given the word problem, we have to be able to write two inequalities. So as I read this, I see Stacy has a $22 app cash card and wants to buy some games and songs, each game Y. So they're telling me games are Y, so I'm going to write Y equals games. And each song X, so X is songs. So they put it in a different order, but they tell me that X is songs and Y is games. Cost $1. She wants to buy at most 17 items. Solve the system of inequality by graphing to determine the possible number of games and songs that Stacy can buy. So they're really just asking us to write our inequalities and graph it. When I go back to the problem, I see that the $22 to buy games and songs, games cost 4 and songs cost 1, those go together because they're all talking about cost. So if every song X costs $1, I would write that as 1X. And every game Y costs $4 plus 4Y. She only has $22 to spend, so spending 1X plus 4Y must be less than or equal to 22. Okay, so that's my first inequality. And then my second inequality, I'm going to write to the right-hand side of it because it's going to require some work to graph. Inequality 2, I see that she wants to buy at most 17 items. So that's a combination of songs and games. But if it's at most 17, that means these have to be less than or equal to 17. Okay, now the whole purpose is to then graph these. If I'm going to graph, I need to label my axes. Remember, X is songs, so I put songs down here. Y is games, so games goes over here. Make sure you label your axes. But I can't graph these when they're in standard form, so I'm going to convert them to slope-intercept. I'm going to start with the blue one since my pen's still in blue. I get y is less than or equal to negative x plus 17. My y-intercept of this would be 17. My slope is negative 1. It's going to be solid because it's less than or equal to, and I can test 0, 0. I get 0 is less than or equal to 17 when I plug that in for these, and that is yes. So I will shade over that. Okay, so now when I go to here, when I started counting 2, 3, 4, 5, 6, I counted by ones. The top was actually 17. So I graph that. And then I would start going down 1 over 1. Okay, so we'll keep going. This is also going to be counting by, actually graph there, 1, 2, 3, 4, 5, 6, 6, 7. Oh, it's not letting me do that. 7, 8, 9, 10. Sorry, it doesn't let me put it there, but so on and so forth. and then I get something like this. Okay, 0, 0 was yes, so it would shade down here. Okay, then we have to switch to the other. And again, in order to graph, we want to subtract the 1x or just x. I'm going to keep it as an x. Actually, I'll keep it as a 1. So I get 4y is less than or equal to negative 1x plus 22. And now I'm going to divide all three pieces by 4. I get y is less than or equal to negative 1/4 x. Remember, I like to keep slope as a fraction because I'm counting rise over run. But the 22 divided by 4, I did type into my calculator, and I got 5.5. Again, I need my y-intercept, so we go fast through the graphing because we've been doing that for a couple of days now. 5.5. My slope, I'm going to go down 1 over 4. So 5.5 down 1 over 1, 2, 3, 4. And I can keep doing that if I want. 1, 2, 3, 4. Down 1, 1, 2, 3, 4. 1, 2, 3, 4. And again, I don't have to be super exact. It is going to be solid. So I'm going to draw a solid line through those points. And if I test 0, 0, I would get 0 less than or equal to 5.5 when I plug in 0 here and here. And I would say yes. So for purple, I also shade down. Don't forget though, your solution is where they overlap. So this region is the solution. And because my lines are solid, anything that falls on the purple line from here to here is a solution. And anything that falls on the blue line from here to here. Also, last but not least, remember we can't have negative items, but I could have zeros. So this axis and this axis are also a solution. Everything in red there would work, meaning any combination on that works for me. So I could have 2 songs and 1 game. I could also have 10 songs and 1 game. Okay, so anything in that region works. All right, one last word problem. We'll do it together fairly quickly. Malia has $500 to purchase water bottles and pairs of socks for a fundraiser for her school's cross-country team. She needs to buy a total of at least 200 items without buying too many of just one of them. What graph shows the possible number of water bottles and pairs of socks? Let X represent water bottles and Y represent socks. So X is water bottles and Y is socks. Okay, so on my graph, the y-axis is socks, the x-axis is water bottles. Now I need to go write my 2 inequalities. Okay? Oops. Oh, I forgot to change this slide. The other information I added, and sorry about that, it did say that the cost of a pair of socks was $3 for socks and $2 for water bottles. That's supposed to be written in there. It'll be in your filled in notes. Sorry about that. So $3 for socks. The reason we need that is because she has a total of $500, so these 3 things go together. So for my first inequality, I would do 2x because x is water bottles plus 3y because $3 per socks. If I only have $500 or Malia, it's got to be less than or equal to 500. Now this time I know I'm going to graph that eventually, so I'm just going to solve it for slope-intercept form. So I get 3y is less than or equal to negative 2x plus 500. Divide all 3 pieces by 3. So y has to be less than or equal to negative 2/3 x. And then 500 divided by 300 was 166.7. I decided to count by 20s. So 0, 20, 40, 60, 80, 100, 120, 140, 160, 180. Okay, because I needed to plot a point at 166.7. And then from there, I also counted this axis by 20s, 20, 40, 60, 80, 100, 120, 140, 160, 180. Okay, it only let me do that. But here's the thing. I can just go down 2 boxes over 3 if my slope is negative 2/3. Okay, so we can get that general idea. Okay. It is solid, so I should do that. So my y-intercept, my slope, and it was solid. If I test 0, 0, I get is 0 less than or equal to 166.7, and yes it is, so I would shade down for the red. Okay. My other inequality, it says she needs to buy at least 200. Inequality 2, so the combination of x and y is at least 200, means that's the smallest amount. So this, the x and y, has to be greater than or equal to 200. So this is a case where our inequality flipped. When I solve it for slope-intercept form, I get a y-intercept of 200 and a slope of -1. Okay, so 180, 200 here, down 1 over 1, down 1 over 1. 200 section hit here. Okay, so looks like that. If I test 0, 0, this time I get is 0 greater than or equal to 200, and that is no, not true, which means for purple, I shade this way. So in this case, the only place of overlap is right in this little sliver between, but also along the x-axis and those solid lines. Okay, so that's the graph. Now using this graph on the next slide, and there's a little bit nicer graph drawn, this is the same graph. Okay, we just said that, I'm going to do it in black this time, that this region right here between the two lines and including them is our solution. Okay, so it's everything in here. But now we want to ask some questions. It says use the graph to made to determine if Malia can buy 75 water bottles. And remember, this is water bottles. And 100 pairs of socks. Okay, so this is socks. So if I go over to 75, so these are counting by 40, so 75 is probably right about here, and 100, this would be 100. Okay, so I would see, does that point fall in that shaded region? And so no, that would not be a solution because it is not in the shaded region. Says what other combinations of socks and water bottles can she buy? Well, that's anything in the shaded region or on the black portions of the lines. Okay, so like this section here across the axis, this section here, or anything in between. Okay, so that whole region, any combination, so 225 probably, so that's 200, 220, and 2. Okay, so that would be in there for sure. So it's a very small little triangle, but the numbers are big. Okay, sorry the video got a little bit longer, but this is your 4-5B note sheet. You can pause it, make sure you have some of that information down. Otherwise, you should now continue on and do your 4-5B Pearson practice. Thank you.